Welcome. Let's discuss the idea of dividing polynomials using the technique of long division. So let's consider the polynomial of f of x, and we want to see what would be the result if we divided by the expression of x minus 2. So we are interested in finding out how we can rewrite the following expression, where f of x is in the numerator and x minus 2 is in the denominator. We're looking for the result of this quotient. So let's set this up. Let's get the expression on the numerator, and let's place this expression inside of a little house. And the expression that we have on the denominator, let's place it on the left-hand side outside the house. So we are done setting this up. Now, before we continue, we have to check certain things. First, is the expression inside the house in standard form? And it is, because notice that the exponents go from high to low. First term, exponent of 3. Second term, exponent of 2. Then the next term has an exponent of 1. And when we have a coefficient, we essentially have an exponent of 0. Let me actually move this a little bit to the left. And now that we have verified that, now we can start the process. What we want to do, we want to take a look at the first term on the outside, which is x, and the first term on the inside, which is 2x to the third. And we want to match them using multiplication. In other words, when we get the value of x, what do we need to multiply by so we end up with the first term on the inside, which is 2x to the third? In order that the value that we need to multiply is 2x to the second, because x times 2x to the second, it does give me 2x to the third. So this value that we need to multiply to connect x and 2x to the third, we will be placing that value on top of the house. And now the next step is we're going to get the whole expression on the outside, and we need to multiply by what we found previously. So let's take one term at a time. X times 2x squared, that is 2x to the third, and negative 2 times 2x to the second, that is negative 4x squared. And notice where I'm placing those values. I want to make sure that I'm matching them up in terms of exponents. Those which had a result of x to the third, I'm going to write down underneath x to the third. And those that have a value of x to the second, I'm going to write it out underneath x to the second. So we are done with that step. Now, the final step is to combine like terms. But before we combine, we are going to change the sign. So this expression was positive 2x to the third. I'm going to change that to negative 2x to the third. And this expression that had negative 4x to the second, I'm going to change that to positive 4x to the second. So very important, before we combine, we change the sign. And now we can combine like terms. So 2x to the third minus 2x to the third, they're going to cancel out. And negative 8x squared plus 4x squared, that is going to give me negative 4x squared. These two values that we have here, which we have not combined any like terms, we're just going to bring them down. And we are done. Now, we got to repeat the process. But notice that it's changing a little bit, because now the first term on the outside, it is x. And now the first term on the inside is negative 4x squared. So those are the expressions that we're going to try to match in terms of multiplication. The expression of x, what can we multiply so that we end up with the expression of negative 4x squared? Well, notice that the value that we need is 4x. X times negative 4x, it will give me negative 4x squared. So now we repeat the same process as before. Let's place that value on the top. And now let's multiply the whole expression on the outside times the second term that we have now. So let's start x times negative 4x, that will be negative 4x squared. And negative 2 times negative 4x, that is positive 8x. But very important, before we combine like terms, let's change the sign. So this term we had as a negative, let's change it to a positive. And this term we had as a positive, so let's change that to a negative. Now let's combine like terms. Notice that the 4x squares are going to cancel out. And now when we combine like terms, 9x minus 8x, that will be just x. And the value of negative 2, we have not done anything to it, so let's bring it down. So let's repeat the same process. The value on the outside is x. The value on the inside is x. So x, what do we need to multiply so that we end up with x? Well, notice that the value is 1. So now that we know what that value is, let's place it on the top. And now let's multiply the whole expression on the outside times 1. So x times 1, that is just x. And negative 2 times positive 1, that will be negative 2. But very important, before we combine, let's change the sign. So x was positive, let's change it to a negative, and 2 was negative, let's change it to a positive. Now let's combine like terms. Notice that the x are going to cancel out, and also 2 and negative 2. So we end up with 0. This value that we obtain at the end of the division, it's very important. It's going to tell us a lot of information. And this value, we refer to it as the remainder. Anytime that we have a remainder of 0, then we can conclude that the expression that we divided by, which in this case is x minus 2, it is a factor of the expression that was in our numerator, which is us, f of x. So we can conclude that x minus 2 is a factor to the expression of 2x to the third minus 8x to the second plus 9x minus 2. In other words, we can get the expression on the numerator, and we can say that that is equivalent to the denominator times the expression that we had on the top, 2x squared minus 4x plus 1. And this is a big result, because now we can use long division as another strategy when we want to factor out expressions. If you find out that after a long division, your remainder is 0, then what you divided by can be a factor, and when you factor it out, what is left is the expression that we found out along the process of long division. Let's take a look at one more example. So now we want to see what would happen if we get the expression of f of x and we divide it by 2x minus 1. Let's set this up. Let's get the expression of f of x inside of a house. And now on the outside, let's place the expression of 2x minus 1. Let's check if the inside of the house is in standard form. We will take a look at the exponents. We go from 3 to 2 to 1 to 0. So we are good. Now that we have checked that, now let's perform the process. Let's start matching. The first expression on the outside is 2x, and the first expression on the inside is 4x squared. So 2x, what do we need to multiply so that it becomes 4x to the third? Well, that will be 2x squared. So let's write that down. And now let's perform our multiplication. Let's get the whole expression and multiply by 2x squared. So let's take it one term at a time. 2x times 2x squared, that is 4x to the third. So let's write that down. And negative 1 times 2x to the second, that is negative 2x to the second. But very important, before we multiply, let's change the sign. So the expression of 4x to the third was positive, let's change that to negative. And 2x squared was negative, let's change that to positive. And now that we have that, let's combine 4x to the third minus 4x to the third, they cancel out. And 6x squared plus 2x squared, that is 8x squared. Let's bring down the 10x, and let's bring down the 4. So now we're done with the first step. So now we got to repeat the same process. First expression on the outside, 2x. First expression on the inside is 8x squared. So 2x, what do we need to multiply so that we end up with 8x squared? Well, that is 4x. Now that we know the value that we need to multiply, let's get the expression on the outside, and let's multiply by 4x. Let's do it one term at a time. 2x times 4x, that is 8x squared. And negative 1 times 4x, that is negative 4x. But before we combine, sorry, I just noticed there's a typo, is before we combine. Before we combine, we change the sign. So the first expression was positive 8x squared. Let's change it to a negative. And 4x was negative. Let's change it to a positive. Now that we have switched the signs, let's combine. First expressions are going to cancel out. And negative 10x plus 4x, that is equivalent to 6x negative. And let's bring down the 4. So now we repeat the process. First expression on the outside is 2x. First expression on the inside is negative 6x. So now we think about 2x. What do we need to multiply? So we end up with negative 6x. That value is negative 3. So let's place that in there and let's perform the multiplication. 2x times negative 3, that's negative 6x. And negative 1 times negative 3, that is positive 3. But before we combine, we change the sign. So negative 6, let's change it to a positive. And positive 3, let's change it to a negative 3. Now let's combine like terms. The 6x's are going to cancel out. And 4 minus 3, that is positive 1. So now notice that our remainder, it's not 0. It is of a value of 1. If we ever end up with a remainder that is not 1, it does not matter what the value is as long as it's not 1, then we can say that what we divided by, it's not a factor of f of x. Which in this case, we can say that the expression 2x minus 1 is not a factor of the expression 4x to the third plus 6x minus 10 plus 4. But there is one thing that we can say. If we reconsider the division of those polynomials, we can rewrite this division. We can obtain the expression that we found out throughout the long division plus the remainder, which in this case is 1, divided by the expression that we were dividing the whole polynomial by, which in this case is 2x minus 1. So notice how much information the remainder can tell us. If the remainder is 0, then we know that the denominator, it's a factor. So we can factor out the expression that we started with. And that factor is the denominator times what we found out throughout the process of long division. And if the remainder, it's not 0, then we can say that the denominator is not a factor. And if we want to rewrite the whole division, we can do so by obtaining the expression that we got throughout the process of long division, plus the remainder divided by what we were dividing, which in this case is 2x minus 1. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.